right now, let's see, let's bring Flynn.
We're bringing Flynn in. Hi, Flynn.
Flynn, Kube Crash alum. I think Flynn has maybe presented at every Kube Crash. It's good to see.
I don't think, I feel like there was one in the beginning before my time, but I'm not sure actually.
Well, fact check that.
Yeah, we'll have to go back and take a look. I also kind of, I mean, I don't know. I feel like if I don't really hit it out of the park in the first couple of slides, I feel like you're just going to kick me off now after you're summarily
that's the power
removing.
We wield. You know, if it's not going well, you're out. No,
we are going to use our power for good and not evil, and you will. And I know people are looking forward to your presentation, so we're going to. We'll give you the floor. Oh, Linky, hey. Oh my gosh, you guys are supposed to do some Linky swag, so I could do this bit in a Linky shirt. That needs to happen for the next. Hit me up at KubeCon so I can.
Well, yeah, I mean, absolutely. Everybody needs Linky. You also need to have a Linky plushie behind you. What are you thinking? You have no Linky plushie.
I have no Linky plushie, but I have the Linky from the Fippy and Friends. I have the Linky, but I'm not at home. If I was home, I'd be holding up the Linky. What is that, like clay thing that they give?
So y'all can put in the comments whether you actually believe her or not.
I have some Linky proof here that I can bust out. I got a sticker in my wallet.
With that,
okay, yeah.
Over to you, Flynn.
Yeah. So I'm here to talk about the possibility that maybe you don't need an army of SREs. And I should probably preface this by saying that I have nothing against SREs. I think SREs are fine people. Really, I do think they're wonderful. But it's fascinating to me to walk around KubeCon and see just how many things are targeted to people working on Kubernetes instead of people working with Kubernetes. And that is interesting to me. I want to talk about the fact that I don't actually think you need to do that to still have a good developer platform. The agenda here really quickly, I'm going to talk some about the current state of the world as I see it. I'm going to talk about how you can maybe start out simply with a developer platform and still get some really good use out of it. And there will be a demo. Now, I saw in a comment earlier, somebody asking about, oh, hey, is this going to be the really deep dive? And kind of less so than some of my other talks. But this whole thing is running on a cluster that is defined with a bunch of source code that I will be publishing shortly. I have to clean up a couple of things after I realized that I was doing them ways I didn't want to be doing them. But if you hit me up, Flynn on the CNCF Slack or the Linkerd Slack is the best way to do it. And I will make sure that anybody who is interested gets linked to the source code for what I am doing here, so you can go study it at your leisure. State of the world. We talked about this a lot at the last Kube Crash, but basically the only way that we've found to develop at scale as opposed to running at scale is self-service development using microservices. The microservices part of that is important because it's the way you get multiple simultaneous development streams. The self-service part is important because it's the way you remove the artificial bottlenecks from your multiple simultaneous development streams. So taken together, this is a big deal. And I went in more depth as to why it's a big deal last time for spring 2024. There's a link to that talk. I'll see if I can't put that in the chat at some point as well. But for this one, I'm just going to take it as read that, yes, this is a big deal. This is the way we want to do things. Specifically, if you look at this, what the microservices architecture permits us is if we have our developer Jane who wants to make a change to that purple microservice, and our developer Jose who wants to make one to this red microservice, they can just do that independently of each other without coordinating, without going through to ops. They can just make it happen. And it's a way that we can allow this to work. So the really big deal about this is not when there's just 2 of them and 4 services. It's that as you add lots and lots of microservices, it's really easy to just add more teams and continue doing things really quickly. So that's the beauty of this whole thing. It is necessary that they have direct control over these things. If you throw in a pass where they have to go over and talk through ops, then that just slows everything down. If you imagine that you have 1,000 developers, then that ops guy is going to have a pretty miserable existence. It's also interesting to note that to get any value out of these things, you have to know how to use it. So If Jane wants to use those other two microservices, she needs to know about their API. She needs to know things like that they exist at a very fundamental level. It's tough to go and use something if you don't even know it's there. She needs to know if they get superseded by new versions. She needs to know how to find the docs. She needs to find out if they're running okay. She needs to know who to talk to if things go wrong. And everybody in your world has to know this about every one of the microservices that you're working with, which is challenging. Ultimately, this thing, all of this ridiculous volume of information, this is what developer platforms were invented to be able to handle, was managing all of this stuff. They have grown to assist in some other stuff right now. Like there's some cool stuff where you can have Backstage go and you can click a button and it'll template out a new application for you and create a GitHub repo and, you know, stuff like that, which is really cool. But at the root of it, the developer platform is really about information and the workflows as well. So this raises questions like, how do you actually get started with something in a way that is simple enough to demo at KubeCrash or to do if there are only 4 of you or things like that? And that's kind of an interesting question sometimes. I want to point out when I'm talking about starting simple, I am referring here to operational simplicity. I am not referring to only being able to do simple things. The point of operational simplicity is that you arrange it so that the people who need a thing can get that thing. In this case, the people who need the thing will be the developers. They need a way, for example, to deploy new versions of their microservice. They need a way that they can get that, and they need to be able to get it without jumping through lots of extra hoops. That's the core point of operational simplicity. Operational simplicity is also the key to avoiding the needless armies of people who are going and working behind the scenes, who aren't directly doing the things that are what you need to get done. Another thing that's important here is to note that operational simplicity does not mean that nobody has to learn anything. So in this particular case, our developers are going to have to learn about how they interact with your platform to get the things done. Development, the software in general, is an interesting field where learning is never optional. You must keep doing it all the time. But the trick here is to try to arrange it so that a developer who's trying to get something done can learn the thing they need to know to get that thing done without having to go off and learn gobs and gobs of details about things that don't really impact them. So it will come as no surprise to anybody who's heard me speak over the last several years that I'm going to tell you that the way you get started with this is by thinking about what your users need. When you're thinking about platform, your users are the people who are using the platform to get something else done. And this is generalizable, right? The users of a particular thing are always using that thing to accomplish something else. So your application's users are the ones who are trying to use the application, not the ones who are working on the application. The users of your platform are trying to use your platform to accomplish something else, like building an application. They're not working on the platform. The folks working on the platform are not users of your platform. That does not mean that they're not important. They are important. They're good, wonderful people, and we like them. But they're not the main concern when you're thinking about what your users need from the platform to allow you to build out a platform that can be operationally simple and still get them what they need. Ultimately, what you really want is this sort of a scenario where you have your platform supporting a ton of users who are all getting useful work done. You do not want this scenario where you have a ton of people who are working on your platform and only a few people who are getting any benefit out of it. But like I said, if you go wander around KubeCon, it is interesting to see that a bunch of people think that, or a bunch of people seem to be pitching products that make it seem like this is what they're arguing you should be doing. Please do not do this. This is not what we want. So what do the users need if we're talking about developers who are trying to use a platform to get something done? the first thing they need is they need to easily be able to deploy things, which is pretty straightforward, right? Of course, there's no point in deploying a microservice if nobody can talk to it. So they also need to be able to get traffic from outside the cluster into the microservice. And they need to be able to get traffic from one microservice to another microservice. And they need control over that, which is its own separate animal in a lot of ways. They need to be able to handle versioning. So if Jane wants to do version 2, that needs to also be an easy thing. The moment you start talking about versioning, now you also start talking about progressive delivery, where you probably would like to go through and feed traffic to version 2, make sure it works. Once everything is happy, eventually you would like to go through and cause version 1 to go away, but you don't want to do that before you know version 2 works. Which implies that as soon as you talk about progressive delivery, you're also talking about observability. So at this particular stage, once you roll out a new version, you need to be able to measure it to see if it's working. Our example here, we would probably decide that version 2 with a 40% success rate is not working very well. And so we should in fact cause version 2 to go away instead of instead of going forward to version 2, it'd probably be better to roll back to version 1 in that particular case. You want secure communications going on with all of this. None of this is helpful if you can't rely on which microservices you're talking to, or if other people can eavesdrop or tamper with things. And finally, as we've mentioned before, you need discoverability. You need to be able to find out what the APIs to these things are. You need to be able to find out dependencies. So in this case, we need to know that the purple microservice always depends on the red microservice. And maybe the red microservice depends on some other things, and we'd like to be able to see that. We'd also like to be able to discover who the owners of these things are, which is, a fair amount of stuff. I'm looking at comments going by about, there will always be a need for developers to understand the internals for when a truly thorny issue needs to be debugged. That's true. At least that can be true sometimes, but an enormous amount of the time, what you find is that the application services are themselves the thing that need debugging rather than Kubernetes. So if you set things up well with the platform and you give the developers enough tooling around this stuff, a lot of the time you will not find yourself down at the pod cider level and things like that, right? So yeah, this is a lot of different things. We've just rattled off 9 different things that the developers are going to need in, a reasonably simple sort of scenario, or a reasonable things that the developer will need to be able to do their work, no matter what their work involves. Fortunately, you can cover these things with 3C and CF projects. We have heard a lot about Argo. It can handle deployments, it can handle versioning, it can handle progressive delivery, which is really nice. Linkerd, of course, as we were talking about Linky there. Routing control, observability, secure communications. All of these are things that Linkerd does very nicely. And we also have Backstage lying around, which can handle a bunch of these discoverability things. What's even nicer about these is that all of these work nicely together. And all of them get to complement each other as well, where Argo plus Linkerd, you get to be able to use Linkerd's observability data for progressive delivery. You can take advantage of the fact that Argo can tweak gateway API resources to do progressive delivery routing control, and Linkerd can then honor those to actually cause the routing to happen. If you have Backstage and Linkerd, there is a pretty young Backstage plugin for Linkerd that permits Linkerd to see permits Backstage to see live Linkerd data about what's going on between microservices and use that to build out its graphs of dependencies and things like that, which is kind of cool. Argo and Backstage, there's also an Argo plugin for Backstage so that Backstage can show you Argo's status and create new workloads that are templated for Argo. Actually, you don't even need the Argo plugin for that. You just need the right template. And of course, sticking Linkerd under the other two permits you to get security and reliability and observability throughout the cluster because, hey, that's what service meshes like Linkerd do. So let's take a quick look over at this demo. All right. So what I have set up over here is a cluster. This is going to be kind of fun. Some of the question here is, how dangerously do I want to live during this demo? I have here a cluster that's running on my laptop. I have Argo, I have Linkerd, I have Backstage running, and I have Argo managing Linkerd so that I can go and change versions of Linkerd with Argo. This is this stuff. Actually, let me switch this over here. So I've got Linkerd running, controlled by Argo. I've got my application, the world famous Faces app, which is actually running okay. And I have the Backstage running with the Linkerd plugin as well. Now, as an application developer who's working on trying to use this platform, probably what I'm going to be interested in is mostly my application. So I would probably just use this kind of a view to only take a look at the part that I particularly care about. One of the things that I like about this combination of tools and the way you can customize things is that you get to choose what's important to you. Let's actually do this. We can do this a little bit dangerously here. So something that I'd like to show really, actually, you know what? Before I do that, let me flip back over here. So one of the things that Backstage gets to do is we can go over and take a look at one of these workloads. If we zoom in on this graph, we get to see that my face workload here is part of the Faces application. It is providing an API called the Face API. It consumes the Color API and the Smiley API. If I then back up from this, I can go and see information about the Faces API, including its definition. The definition of the Faces API, the particular Face API isn't all that dramatic. I can look at the things it consumes. I can get the definition of these. All of this stuff is just there for the taking for anybody who wants to look at it. If I come back over here, I'm again looking at Face in the middle of it. I can click on the Linkerd tab. I can see that the Faces GUI is talking to the Face workload, which is talking to Color, and talking to Smiley. All of that is stuff that is live from Linkerd, so that I can also go through and look at things like, oh, look, I'm making an outgoing connection to the Color workload, 7.2 requests per second, 100% success rate, which is really nice. And this, again, this is all live. So from this, without going through and doing a lot of other work, if I'm a developer, I can go and see what's up with this workload, what it needs to talk to, what is talking to it. And I get to see that without having to go and bug anybody, without having to go and talk to anybody about all of the little details. It's just there and easy for me to see with a single pane of glass. So the way I did that, since we had some folks who were asking about that, there are a couple of different things going on here. This is the main GitHub repo that I'm using for this demo. A lot of this is stuff that's about the demo as opposed to about Argo or about Backstage or anything like that. The really important stuff here happens down in the ArgoCD directory, though. And probably the most critical bit here is this one YAML file. Where the lion's share of this is just saying, hey, look in this GitHub repo, look in this directory within this GitHub repo, and look at this branch. Put it in the faces namespace in my default Kubernetes server. There's some boilerplate there. This is all stuff that can be templated as you create a new thing. So if a developer is creating a brand new service, they have an easy way to go and just fill this repo out, create it, and then have it be alive in Backstage and in Argo, and they'll be able to see it, which is really nice. Also in here, we have the related stuff for Linkerd lives in there as well, but that's probably going to move into a different repo before I publish this, because getting Linkerd running is really part of the platform, not part of the application. So that's why I say I'm going to be publishing this shortly, because I want to go ahead and split this out so that as an application developer, you wouldn't have to think about Linkerd at all, which is the way you should be thinking about Linkerd as an app developer. You shouldn't have to care about it much. Let's see, what else is relevant in here? Honestly, that's most of it. Now, let's try something else as well. So what we should be able to do is, as a developer, we should be able to make simple changes to affect how our application is operating, right? If I look here in my faces directory, I have this color.yaml file, which tells me everything that I need to know about the color workload. And again, if I go back over to Backstage, I can come over here and I can look at Linkerd and I can see, oh, my face GUI is talking to my face workload, which is talking to my color workload. So if I look back over here and I go, well, okay, so if I want to change this color to be green instead of blue in the background, that's probably the color workload, right? So if I come back over here, question, could I do this if I'm using Istio as your service mesh instead of Linkerd? Yes, but why would you do that? Much less facetiously. Okay, on the one hand, I'm biased, right? I work for Buoyant. We do Linkerd. I like Linkerd a lot. Linkerd is cool. A much less facetious thing about that, though, is that Istio is more complex than Linkerd. There are things that Istio can do that Linkerd cannot do. Let's be fair, 100%. But Linkerd has spent its entire life focusing really hard on operational simplicity. And it's really tough for me to recommend that if you're a small startup who's trying to put together a simple platform so that you can get a lot of stuff done that's not working on your platform, it's really tough for me to recommend anything but Linkerd because of that focus on operational simplicity. And that is nothing that I haven't told the Istio maintainers. So, you know, they know that already. So let's live a little bit dangerously here. Azure AKS has support for Istio out of the box. I'm pretty sure Azure also has support for Linkerd in the marketplace too. So now that I've said that, it'll be fun to have somebody check that and find out. Have I implemented zero trust in the service mesh? Linkerd pretty much natively does zero trust in the service mesh. This is a thing that Linkerd just does well. If you want to get a little bit more specific about that, every workload gets a cryptographic identity from usually based on the Kubernetes service account. And everything that Linkerd does automatically is MTLS, authenticated on both ends. So every request you are doing is authenticated. Every request is checked every single time, wherever it's coming from. Yeah, it's pretty much built for the zero trust world. Raymond says, Istio has gotten a lot easier. That is true. I am not going to argue with that fact. but I still think Linkerd is easier than that. So I've just made a change here where in a lot of situations, if I want to change something about the color here, I would go through and change the source code and recompile it and all of that. And in this particular case, I just have to change an environment variable. So that's all I'm doing. But if I do that, this is GitOps. So I'm going to go and add this file. This is also where people are going, wait, Flynn, you're actually typing instead of you running the script that does all this for you. Yeah, I decided I was going to live dangerously this time. So if I do that, and then I flip back to my web browser, if I look over at Argo, let's go ahead and manually trigger a sync on this app. You see how it says switch to green now here? So that change has come through. And hey, look, I've got green stuff. Isn't that awesome? Yeah. Let's see, backing up. You can do Linkerd from, I assume you mean the Azure Marketplace, but only if you're using Enterprise. Oh, okay. Well, as you point out, Robert, it's not exactly difficult to deploy Linkerd Edge as well. Gabriel asks, where do the workloads get the identity? And workloads in the Kubernetes cluster, it's based on their service account. So if you change the service account, you change the identity. Let's see. How are we doing on time? Hey, Danielle and Lisa, how are we doing on time? Y'all want to come back?
We didn't know if you were pausing to think about the time or not.
I looked up at my clock and realized I don't actually know what my clock means right now. So
I know we were pondering that thought too. No, you've been doing a good job going through the questions. Was there another main point you wanted to make? Because we are running behind, but we definitely want you to have the time that you were promised.
I think that I am going to stop here because hopefully that'll give us a chance to cover a few more questions. And there are things that I could do from here, but they are increasingly becoming things that would require sacrifices to the demo gods. So this might be a good place to stop and make sure there are no more questions while things are going well.
Yes, that sounds good. And as we mentioned to you in previous Kube crashes, the demo goddess is the one you actually want to make your sacrifice.
You know, that's what I get for reading the comments and forgetting.
Yes,
how could I forget?
Yeah, forget about him. He's useless. It's the demo goddess that runs this show.
Yeah. A couple of KubeCons or a couple of Kube crashes ago, actually, we did not pray sufficiently to the demo goddesses, and my demo. Ooh, wow. Let's just say you can really tell.
It wasn't just you. There was one Kube crash in particular where all the demos, she was angry that day because, her counterpart was getting all the prayers.
Yeah, exactly.
Don't forget about me.
So you have a lot of great comments coming in. Ermin, if I pronounced your name correctly, would love to have you get repo and play with this. And then Robert wants to speak to you, pick your brain. And
we can do those things. Again, the easy way to find me is as Flynn on the CNCF Slack or the Linkerd Slack. I assume that we can post links to those Slacks. But
yes, and I think my favorite comment of the day now is from Mike J. Bring Crash to the Cube. Great.
Oh yeah.
All right. Thank you, Flynn. If you can add links to those channels, answer any additional questions. It's always a pleasure to have you here.
And all the Argo channels, these guys were doing like happy dances during all your demos and your slides. So they thank you for all the shout outs.
Yeah, there's probably no point in going back to the slide deck for the summary slides, but the summary of all this
added back in.
I don't think there's any point. The real summary is you don't actually have to go out and hire a ton of people and build your very own developer platform from the ground up. You can go through and just grab some of the CNCF things, put them together. Yeah, there's a little bit of a learning curve, but that's part of why we do these repos and then publish them, is so you can go through and take a look at it. It's not actually that hard. And it will put you in a situation where you are in a better place because your developers get to focus on being developers. And then, yeah, maybe every so often, one of your guys is spending half a day going off and being an SRE to work on the platform, but you don't have to suck a lot of time into it. Let's see. Did I miss anything else in the questions? One objection I've seen, says Joe Thompson, to this kind of super visibility for folks outside the ops team is a bad actor can use all this info to attack us. Yeah, it's okay. Do you want the security weasel take on this, or do you want the normal person take on this? The security weasel take on this is you go back to them and you say, what exactly is your threat model? And then you have a long discussion about that. And the normal person view of it is, what are you really worried about, right? Tell me the thing that is scaring you. If you're scared because going, oh, hey, the developers can see things outside of, oh, okay, are you telling me you don't trust your developers and you're going to let them write code anyway? If you don't trust them at all, they shouldn't be doing things on your cluster. If you trust them a little bit, set up cluster RBAC, right? But just knowing the name of the workload is unlikely to be a serious threat unless you have some really, really weird, crazy stuff going on. If you do have weird, crazy stuff going on, maybe you are in a position where you need a dedicated ops team to interact with your dedicated security team, and that is okay. But you probably don't need to start there on day one when there are only 4 of you, right? Yes, obfuscation is not security. Security through obscurity is, as Schneier puts it in applied cryptography from 30 years ago or something like that. Security through obscurity is the kind of security that keeps your kid's sister out of your file. And we want the kind of security that keeps major world governments out of your files. Yeah.
All right. Well, with that, we are going to actually...
They're going to boot me off. I told you. Yeah.
Thank you so much. And, again, if you have more questions for Flynn will hang around and answer that. And with that, we'll see you later.
Thanks, Flynn.
Thank you. Always a pleasure.